All right, here we go. This is 12.3. 12.3 is known as measures of dispersion, but it really truly is just basically calculating standard deviation. And we know that standard deviation is essentially the measurement for how spread out your data is. The bigger the standard deviation, the more your data is spread out. The smaller the standard deviation, the less your data is spread out. And it's spread out in relation to the mean or the average. Does that make sense? So we have a data set like we've been doing. Every data set has an average or a mean. And your SD or your standard deviation tells you a little more information about it. Just like you can calculate mean, median, mode, mid-range. Standard deviation is just another piece of information about your data, a way to look at your data. And that component is how dispersed it is. Okay, so let's just answer this first question, which is not really that big of a deal. Find the range for the group of data items. Okay, well, the range is simple. Remember last class we did mid-range, right? Mid-range was the average of the low and the high value. Range is just the difference between the two. Does that make sense? So if I want to know the range, I take my high, I take my low, and I subtract them. So the range is what here? 4. That's it. Done. Does that make sense? Okay. So there it is. Real quick, go do the range for this one. Real quick, go do that range. Okay. All right. So what's the range for that one? 13. It sure is 13. Any questions about that at all? Okay, that's pretty minor. I'm going to skip number 3. It's not the same thing. It's the same thing. Let me back out here. All right, now we get into the actual standard deviation work. So the range, so you have mean, median, mode, mid-range, range. All those are ways to look at your data, right? Now we actually get to the meat of this section, which is standard deviation. The first step to figure out how dispersed your data is and to calculate your standard deviation. So standard deviation is synonymous with dispersion. Okay? Step 1 is to always calculate the mean, x bar. So as you can see here, the first step, they walk you through it. They walk you through how to calculate the standard deviation. Does that make sense? So they say, okay, here's your data set. Find the deviation from the mean. Well, they already gave you the mean. But if you were starting, which in a moment we will, in a moment, all they're going to give you is a data set. And you need to know how to go through all the steps to figure out the standard deviation. The first being that you need to calculate the mean. Does that make sense? Okay? Well, they already did that for you, so now we can move on to the next step. The next step is to calculate the deviations. You'll see me abbreviate it as DEV, okay? Just like you might see me abbreviate standard deviation as SD. All right, so to calculate the deviations, what do they mean by the deviations? Well, we calculated the mean, or they calculated it for us. And now we need to find the deviation from the mean for each of the data items. So that you create a table. Now, what I want you to understand is that normally, actually, you would want to create the table vertically. So I'm going to actually show you how to do this table in a vertical format. Okay? So we would normally write 15, 25, 35, 60, 90, and we have one more, 135. You with me so far? Okay? So normally you would set this up vertically, and you're going to see it happen much more. Then you would calculate the mean to then be able to calculate the deviations. Okay? So step 2, deviations. All right, so let's go figure out exactly. I've gone around and around, all to tell you to do this. What is the deviations? Very simple. Deviations is the difference between each value and your mean. Okay? The deviations is your x value in your data set minus the mean. Not the other way around. Not the other way around. So for example, if I want to calculate the deviation of 15, the deviation for 15 is going to be 15 minus 60. Does that make sense? So therefore it's going to be negative 45. Right? Because 15 minus our mean of 60 would be negative 45. You with me so far? So now let's do the deviation for 25. 25 minus 60, which would be negative 35. Deviation for 35. 35 minus 60, negative 25. Deviation for 60, 0. 60 minus 60. Deviation for 90. 90 minus 60, 30. Deviation for 135. 135 minus 60, 75. Does that make sense, everybody? Okay, so just double check my work, of course, because I can easily make a mistake, but that is what you would do, okay? So I'm going to just type these in just so you guys can see that we did a good job. So we have what? Negative 45, right? Negative 35, negative 25, 0, 30, and 75. Make sense? Okay, so there it is. Now, the next step in figuring out standard deviation, step 3, is to find the sum of your deviations. Okay, so the sum of all of your deviations, also done this way, x minus x bar. So the sum of all of your deviations. In other words, the sum of everything you did in step 2. Sum means what? Add, subtract, multiply, divide. What does it mean? Add. So right here, we're going to add all these up. Tell me what happens when you add all of them up. What do you get? What do you get here when we add all of these up in step 3? Yeah, and what's the answer? Somebody got a value? So there's the end of step 2 there, and we are on step 3 right now. It is 0. And it will be 0 every time. The sum of your deviations, or step 3, is always a checkpoint. It's a check. We're not done. We haven't found the standard deviation. We're about halfway through the process. But you want to generally do step 3 because you don't want to, there's an easy way to make a mistake here, isn't there? You could make a mistake calculating your mean, and if you make a mistake calculating your mean, you're going to make a mistake on all of your deviations, which will probably cause this to not be 0.
So it needs to be 0.
It needs to be 0. Every time. It's a perfect checkpoint. Does that make sense, everybody? Okay, so, question?
Never mind.
Okay, so always make sure that step 3, it should always equal 0. Okay, if it doesn't, you need to go back and check your work because you probably made a mistake. Okay, so that's it for that problem. Okay, so what I want to do is I just want to kind of skip forward. I don't want to do another one of the first 3 steps because we have to do it anyways for future problems. So you now know the first 3 steps. We're going to get to a little bit, and let's do this one now. Okay, so they don't. So we are going to do the first 3 steps of this one. They don't give you the table. They don't give you the mean. They don't give you at anything to work off of. You have your own data set now. Does that make sense, everybody? So let's have everybody go through the first 3 steps for this data set. Okay? So we're going to go through the first 3 steps for this data set. Let's get started. First and foremost, without them prepping you, right? Without them prepping you, you have a data set. We need to calculate the standard deviation. What is the first thing we do? Calculate the mean. Exactly. Okay? So step 1, period. There's no going around it. Your first thing that you need to do is calculate the mean. Somebody got the mean for us?
I got 85.
85? Okay. Why don't we double check that? Actually, let's not even double check that yet, shall we? Let's go through the whole thing and get to step 3. Okay? But do we have a confirmation?
I got it. 83.
83? Okay, let's not do the whole thing.
Is that a 57?
Let's try 85. 85. So it is 85. Okay? So double check your work. Now, forget this table, right? I kind of didn't want to have like this table show up, but it's okay. So here we go. Let's create our own table right here. So x values. Then you're going to need to know your deviations. So here are our values: 67, 97, 82, 67, 112. Okay?
I thought one of them was a 5.
That's okay. No worries. So now, let's calculate our deviations. Deviations are always what? Your x value minus your mean, not the other way around. I'll say it again. Do not take mean and subtract x value. X minus your mean. So what's the first one, everybody?
Negative 18.
Negative 18, good. Second one? 12, I think. Is it 12? Third one? Wait. Negative 12, right? No, 12. 82 minus 85, negative 3. Next one, back to negative 18. And then the last one is what? 112 minus 85, 27. Is that correct?
Yes.
Okay. Make sure you're able to do this, or you're working on your own problem. Doesn't matter to me. Just make sure you're being productive. So now, if we do a good job, what should the sum of our deviations be? 0. And are they? Are the sum of our deviations 0?
Yes.
They are. So we know we've done a good job. Does that make sense, everybody? Okay, I don't want to type this all in. I don't even have to type it in because the sum of the deviations is 0. I know we did a good job. Got it? Okay, so there it is, done. Let's move along. We have practiced the first 3 steps. I don't want to do number 7 because it's the same stuff. I don't want to do number 8. It's just decimals. It's no big deal. Same stuff, and you guys have a calculator, which is great. Now, we get to an actual standard deviation problem. Let's go through the entire thing, okay? All right, here we go. So, straight up they go, find the standard deviation. Well, I told you that. This is only about halfway through the process, right? So, I'm going to show you the rest of it. Let's go through the first 3 steps, shall we? First 3 steps in our finding our path to getting the standard deviation are all still the same thing. So what do we need to find out first, everybody? Mean, exactly. Step 1, figure out the mean. Anybody got an answer for it? It's going to be 5. Good.
25.
No, you got to divide by 5. Can't be 5.
Oh, yeah.
Yeah, remember, your mean should never be a number that lies outside your data set. Now, let me clarify that. It doesn't have to be a number in your data set, but as you can see, 25 is way out here. And if that's supposed to be the average, right? There's no way the average of 3, 4, 5, 6, and 7 can't lie or can lie outside of the range of 3 and 7. Does that make sense? So let me say that one more time in another way. Your mean does not have to be 3, 4, 5, 6, or 7, the numbers themselves. But what it has to be is it has to lie within the range of 3 and 7. Does that make sense? Otherwise, how could that possibly be the average? Okay, so perfect. All right, step 2. Let's go create our chart. Everybody agree? Okay, so we create our chart. We first start it with your x's, and that's 3, 4, 5, 6, and 7. Then we create a column for our deviations, and now let's go calculate our deviations. 3 minus 5, negative 2. 4 minus 5, negative 1. 5 minus 5, 0. 6 minus 5, 1. 7 minus 5, 2. Let's double check our work. Does that equal 0?
Yes.
Sure does. So we are on the right track. We have passed the first 3 steps towards finding our standard deviation. Does that make sense, everybody? Okay. Now, the 4th step in finding standard deviation or calculating standard deviation is to square your deviations. So you're going to square the deviation. So you're going to, in step number 4, create another column for the deviations squared. Okay? So another column needs to be the deviations squared. Let's take a look here. So deviations squared. Well, let's go do it. Negative 2 squared is positive 4. Negative 1 squared. Negative 1 times negative 1, positive 1. 0 squared. 0. 1 squared. 1. 2 squared. 4. And there we're done with that step. You with me so far? We good? Okay. Now, next step. Step 5. You're going to sum your deviations squared. Okay, you're going to add up all of your squared deviations. Okay? So you should, in step 5, get a value for your deviations all added together. Your squared deviations added together. 4 and 1 is 5, 5 and 0 is 0, 5 and 1 is 6, 6 and 4 is 10. Everybody agree? Okay? So we're done with step number 5. One more time. Step 1, step 2, step 3, step 4, and step 5. You with me so far? Okay? Now, step 6. You're going to take your answer from step 5. You're going to take your sum of your squared deviations, and you're going to divide it by the number of elements in your data set minus 1. Okay, so let's come over here. What did we say? We're going to take our answer from our sum of squared deviations. We're going to divide it by simply the number of elements, which is 5 minus 1. So in step 6, you just take your answer from 5 and divide it by n minus 1. So if you want to simplify it, you can just say, okay, I take my answer in 5 and divide it by n minus 1. That's another way you can look at it, right? So you just take that answer, divide it by the number of elements minus 1. So that is really what? 10 over 4. Agreed? Somebody tell me what 10 over 4 is. 2.5. And we're almost done. Last step. Take the square root of your answer in 6. And that's your standard deviation. So your last step, step number 7, is to take the square root of your answer in 6. And somebody got that value rounded to 2 decimal places? 1.58. There you go. And that is your standard deviation. And I'll talk to you about the relevance of that in a moment here. So let's just type this one in here, 1.58, and there we are. Does that make sense, everybody? It's a long process. It really is, and it's not easy, but it's very, very manageable. Okay? So let me talk about this and how this relates to your data set, shall we? Okay? So this is a normal distribution. Typically, it's not a perfect line, but that's okay. You have your mean. Your mean is essentially the average of your data, okay? One standard deviation should cover the majority of your data. So in other words, for example, taking a look at our problem, our mean is 5. Everybody agree? If I go one standard deviation, if I add a standard deviation to 5, I would be at what? 6.58. Everybody agree? So the difference here is one standard deviation. Agreed? If I go one standard deviation below 5, what's 5 minus 1.58? 3.42. That's one standard deviation in the other direction. So I have my mean, one standard deviation above it, one standard deviation below it should cover, I believe it's 76% of the data, don't quote me on it, it's something like that. And we'll look at it when we get to the normal distribution next class. Does that cover almost all of those data points? 3 doesn't quite fall into there, 4 does, 5 does, 6 does. 3 out of 5 points, the majority, are covered within there. Does that make sense? If I add another standard deviation to it, I add another standard deviation to this side, oops, will I cover all of the points in the data set? Yes. And 2 standard deviations typically covers, I believe, 98% of the data, something like that. We'll look at it next class. Does that make sense? Okay. So when we do the normal distribution, which I'll talk in detail about, that is what we will discuss, is the relationship between your standard deviation and the coverage of your data set. Okay. So, and then we'll talk in detail about how this relates to populations and grades and all sorts of different ways of applying it. All right, but now this section is all about standard deviation. Now you have an example. I don't want to do this one because it's so simple. Let's do a little bit more complicated standard deviation one, and I want to do that one. Let's put these two easy ones. Let's do this one, shall we? Okay, so here's what I want to do, okay? I want to do sample A, the standard deviation for sample A. Okay? I'm going to erase all this and go through it again. Okay. All right, so you have your notes on how to calculate the standard deviation. This is a textbook problem. Why? Here's a data set, and they ask for everything, pretty much. Now, if I had a data set, I could ask you, literally, I could give you one question, and you could be able to teach me everything from chapter 12 off of one question, couldn't you? If I gave you a data set, you could get mean, you could get median, you could get mode, you could get mid-range, you could get range, you could get standard deviation. You could do all those things and show me your understanding of like a very brief introduction to statistics just from that data set. So let's go do the mean part of it, right? So somebody tell me what the mean is for this problem. Somebody got it? $33, okay. So right now, we're going to say the mean is 33. Just real quick, why don't we answer the question on range? Somebody tell us the range. Should be easy. What is it? 24. 24, good. All right, now let's go calculate standard deviation, shall we? All right, so standard deviation calculation, you're going to have to set up your table. X, your values, your deviations squared, right? Those are the 3 things that have to happen. Step 1, calculate your mean. We already did that, right? Step 2, we need to calculate our deviations. Step 3, we need to check our work. Everybody agree? Step Step 4, we need to figure out our deviations squared. Step 5, we need to sum those, add them all up. Step 6, we'll go on with in a moment, okay? But for now, we have a little bit of a task in front of us. First, let's lay out our data points. So we have 21, 25, 29, 33, 37, 41, and 45. Okay, so 21, 25, 29, 33, 37, 41, and 45. Let's go figure out first the deviations for it. 21 minus 33, negative 12, right? 25 minus 33, negative 8. 29 minus 33, negative 4. You guys could all do this. 33 minus 33, 0. 37 minus 33, 4. 41 minus 33, 8. And 45 minus 33, 12. Okay, and I want to make one quick comment here. Do not always expect there to be a matching data point and mean. Don't always expect that. That's not always the case. Does that make sense? And also, don't expect your deviations to be symmetric. Does that make sense? It's not always that way either. Okay? So this just happens to be a problem where your mean happens to also be a data point, and your data point is perfectly spread out. Okay, it's symmetric. So you really would have a perfect curve here. And sure enough, does it check out and make 0? It does, right? So this step 3 tells us 1, we calculated the mean correctly. 2, we calculated our deviations correctly. Now, let's go square the deviations. Negative 12 squared, 144. That means 12 squared is also 144. Negative 8 squared, 64. 8 squared, 64. Negative 4 squared, 16, 16, and of course that's 0. Again, this is just a nice problem because they have essentially the same values, mirrored. All right, did somebody already calculate the sum of the square deviations?
48.
Say that one more time.
448.
448, wonderful. Thank you. So 448. Now, step 6. We need to take our 448, the sum of the squared deviations, and we need to divide it by what? Not 2, 4, 6, 7, but 6. 7 minus 1. So you need to divide your sum of squares by 6. Number of elements minus 1. Come back here, that's exactly what we did. Step 6, divide your sum of squares by the number of elements minus 1. What do you get? 74.67. Okay. Is that rounded or not? It's rounded. Okay. Perfect. And then now what do we need to do? Step 7. Take the square root of that. 74.67. Oops. What's the square root of that? 8.64. Okay. If for some reason that piece is off, we may not want to round it so early. But let's just see what they have to say. So let's type in our values. So our mean is 33, our range is 24, and our standard deviation is 8.64, and we nailed it. Good job. Does that make sense, everybody? Is it really that hard? No. It's just lengthy. Just a lot of steps. But it's not bad at all. Okay? Are there any questions about that? Is that recording? Mm-hmm. Perfect. Thank you. Everybody got that? Okay. Let's do one more, and that'll do it for us. Let's go and do sample. Let's do sample. Let's do sample B. Let's do sample B. That's good. Okay. Okay. Let's do that. And that'll be the last problem we do. right, here we go. So, sample B, we just calculated sample A, that's all done. We're on to our last problem here, which is sample B. Let's go calculate the mean for that to get started. So the mean for sample B, somebody got a value for that. It's going to be different because your data points are a little bit different here. You got a value for that. Ah, 33 again. Well, well, well. Okay. I really wish we didn't have a problem where the mean and one of the data points were the same, but whatever. Range, same range, right? This one's the same range as the other one. And so let's go calculate the standard deviation. So we're going to need an x column, a deviations column, and a deviations squared column, right? Our x values are 21, 23, 25, 33, 41, 43, and 45. Let's go calculate the deviations, shall we? 21 minus 33, negative 12. That's the same one. 23 minus 33, negative 10. 25 minus 33, negative 8. 33 minus 33, 0. 41 minus 33, 8. 43 minus 33, 10. 45 minus 33, 12. Now, what do you notice here? They created another symmetric data set, but with a little bit different values, right? Okay. I think the reason why they did it this way is they wanted to show you that different data sets, even slightly different, can have the same mean, right? They can have the same mean. And of course, if you check it, sure enough, the sum is 0. Okay? So now let's go square deviations. 144, 100, 64, 0, 64, 100, and 144. Is there somebody that's ahead that can tell us the sum of the square deep? 616. Okay, perfect. Thank you, guys. So the sum of your squares, that's another way of calling it. The sum of squares is 616. And so now we're going to take 616, divide it by 6 and minus 1.
No.
Yes, you got it. And so what is that?
102.67.
102.67. And then we're going to take the square root of it and answer 10.13. There's your standard deviation. What was the standard deviation on our previous problem?
8.64.
Yes. In other words, what is going on in this one? The data is a little bit more spread out. And isn't that true? Because this 25, so same, same, same. But 23 and 25 are a little bit further out from that mean. Well, the mean ends up being 33. And here, so your mean is 33. It's just coincidence. And isn't that true? These two and these two are a little bit pushed out. And that is why our standard deviation reflects that. Does that make sense, guys? Okay, so sure enough, 10.13, I'm not going to type it in. It's good. There it is. Does that make sense? And that's all. So that is it for 12.3. You guys should be in good shape.